Not only is this system economically broken, it's fundamentally broken from an environmental standpoint.
Are you ready? All right, let's go.
Manufacturing is sexy. Sounds crazy? Just wait. I'm Z Holly, host of The Art of Manufacturing. Your behind-the-scenes look at how people who make stuff are trying to make it in their industries. If you've ever wondered how to build a brand, a business, or just a better mousetrap, tune in and enjoy. Hey everyone, it's been a while since our last episode, and I missed you crazy people. Although we're not quite ready to launch season 3 yet, but I recently visited a fascinating car factory called Divergent 3D, and I couldn't wait until next season to share. The CEO and founder, Kevin Czinger, totally blew my mind with his thinking around how to make cars more sustainable. We're going to bust some myths this episode because it doesn't involve making them all electric. You'll see what I mean. But first, I'm wondering how many of you are going to Westec next week? Westec is the big manufacturing show in downtown LA, September 12th and 14th. I'll be moderating a lunchtime discussion on Tuesday, and if you want to go, stay tuned for an exclusive comp code for the Art of Manufacturing listeners. The conference is hosted by the Society for Manufacturing Engineers, and I'm thrilled to have a chance to have a conversation with Jeff Krause. He's a CEO and executive director. I wanted to learn more about what we can expect at the show, and given he has a finger on the pulse of what's going on in manufacturing, I wanted to get his perspective on the business and technology trends we should keep an eye out for. If you sort of summarize in one sentence, what is the mission of SME?
Our mission is to attract future generations to manufacturing and promote the advancement of manufacturing with technologies.
You know, we hear so much about needing to bring manufacturing back to the U.S., and there's a lot of discussion and disagreement about, can we do that? How do we do that? Does manufacturing need help right now?
Well, manufacturing needs help, but it's not in life support. Manufacturing is constantly changing, and so much so that it's absolutely exciting. When you get to talk with a lot of our customers and a lot of the experts in manufacturing, and you see manufacturing in practice on the floor and the changes in the use of technology, it is really, really amazing. So
now you're just saying that, right?
No, I am not saying that. I actually believe it. It is so true. So
I am really excited about the conference, and so maybe you could tell us just a little bit about the event. What's the purpose of it?
Well, the purpose really is to bring people together to learn about new technologies, how they're applied, and how they can take back an education about the new technologies. It's bringing buyers and sellers together. We're going to have 15,000 different people attending, the show over the days. So we're going to have over 100,000 of net square feet. We're going to have over 500 companies. It's really going to be an incredible display of new technology, as well as keynotes and all kinds of forums where people can learn and engage in conversation about what is changing manufacturing. There's going to be a huge number of attendees that have roles in manufacturing companies that are coming to evaluate technologies and recommend investments for their companies.
I hear that there's a really great session at lunchtime on Tuesday. I'm just saying that because I'm actually emceeing that event.
Well, Lunch and Learn with Z, talking about how to utilize California's manufacturing resources. I think that's one of the dynamic events coming up.
Yay. So I'm curious what you're personally the most excited about seeing at the conference?
I love to hear some of the new technologies in play. And we're going to have, for example, the Chief Strategy Officer of Local Motors, Justin Fishkin, and he's going to talk about how, technology advances in transportation and what Local Motors is doing. We're going to have people talk about how to help train the workforce. And that the skills gap in manufacturing, Z, is a huge obstacle for advancing manufacturing. So we're going to have a panel about California training funds talking about how manufacturers can get access to funding to take advantage of initiatives to help train what is needed, and that's a highly skilled, technically trained workforce for the new jobs in manufacturing.
And what's frustrating to me sometimes is that when I speak with educators and schools, et cetera, they actually don't know what's necessary. And I'm wondering how do we bridge that gap? And what are if you could pick 3 top skills that are really missing and that schools could really do a service if they were to focus on that, what would those be?
Oh my gosh, that's a really great question. First, I'll talk about a couple of the jobs and what's happening. Understanding technology, and as much as that may sound cliché-y, we're talking about how can you use the Internet of Things, applying that in manufacturing. How can you do digital design? How can you apply 3D printing? But let's go back to some of the basic technologies that are core to manufacturing, like CNC operators and how 5-axis CNC machines and automation and robotics are changing. And that's not even mentioning just the huge avalanche of what's going on in 3D printing or additive manufacturing.
Sometimes I feel like we have a love-hate relationship with manufacturing. We want to bring it back, but nobody actually wants to work in manufacturing. And why is it that people don't want to? They're so, I think I know why. There's this meme that automation is going to take all the jobs, and they've already taken all the jobs. And so there's really no future.
The truth is contrary to that, absolutely. There's going to be strong openings. And right now, there's hundreds of thousands of jobs that are unfilled. We've got various customers that we work with in our Tooling SME, which is our training unit, and they're considering how do they expand their manufacturing footprint. And one of the considerations they're using is the availability of trained workers in those geographies. So some people are picking plants and manufacturing locations based on the availability to draw in the talent. So there's really huge opportunities. There's a misperception in general about manufacturing, thinking of it as the old kind of manufacturing. It is different than the way it used to be. It's different from when I started in my automotive career, 30-something years ago. Manufacturing is absolutely changing. It's clean, it's fresh. There's all kinds of ways to increase innovation and productivity with the use of technologies. And we've got to get that image out there. Now, I used to think that young kids, let's talk about high school kids or middle school kids, that they had this negative impression of manufacturing. But you know what? We found that that's not really true. It's the parents or the guidance counselors. It's people that don't really, an older generation that's thinking of manufacturing in an old way. What I find is young kids go, wow, that's how something's made? Oh, you mean I could do that? You mean I can do a 3D design on a computer and I could 3D print it? And so young kids, what we love to do is bring them in and show them what the capabilities are in manufacturing and inspire them to consider careers in manufacturing.
Oh, that's great. Isn't it true, though? It seems like some of our best qualities as human beings are totally kind of taught out of us by the time we're adults. And maybe what we need to do is not focus on the kids. I mean, we do want to focus on the kids, but focus on the parents, too. We should all just say together, manufacturing is sexy.
When you talk to kids graduating from high school, let's ask young people, what do you want to do? Because there's a lot of different pathways for them. They can go into career tech education. They can go into engineering school. They can go into liberal arts. They could go right into the workforce. But the answer for all kids doesn't mean you have to go to college. Let me throw one stat out to you, and that is the average manufacturing worker in the U.S. earns $81,289 per year when you include pay and benefits. There's great opportunities.
Your background, you come from the automotive industry yourself. And we have a guest later in this episode, and he's from Divergent 3D. I don't know if you're familiar with the company, but they're creating these micro factories to use 3D printing to make the whole process of automotive manufacturing more sustainable. And I'm curious what you think about the different technologies that are making automotive manufacturing more innovative.
Oh my gosh. Automotive is a huge vertical within the manufacturing field. And I spent 30 years in the automotive industry at General Motors and Delphi. Everything about manufacturing that's exciting, and that's electrification of powertrains, determining when it is appropriate to use additive manufacturing. You can always make something additive, but should you? Is it cost effective? So figuring that out. And then when you consider the industrial Internet of Things, IIoT, and how you can have, smart equipment, smart machines, smart processes that provide a constant feedback, and it even can lead back to the product designers on how to change the design for ease of manufacturing.
We're almost seeing a democratization of manufacturing in a way. And there's going to be a lot of these technologies at Westec. Can't wait to
Absolutely.
go. And I'm curious, how can people learn more about SME and Westec?
Come to sme.org. And I know that you can come to westeconline.com.
Great. Thanks so much for chatting with us. We're looking forward to it. And the future looks bright. Thanks for joining us.
The future's bright in manufacturing. And Z, thanks. You're very knowledgeable about this, and we're going to look forward to your panel next week.
I'm so excited for the show next week. If you're interested in attending and haven't already bought a ticket, you can visit makeitinla.org/Westec, and you'll get a complimentary pass. And then register for our free lunchtime discussion on Tuesday. We're having a wrap session aimed at local manufacturers to learn how to tap into resources and incentives. If you're in LA, I hope to see you there. Now, back to our conversation with Kevin Czinger. Get this, we've built 2 billion vehicles in the last century, and some project another 6 billion cars will be made in the next 35 years. These cars will have a huge impact in the environment. So, we should aim to switch all our vehicles to electric, right? Well, not so fast, says our guest this week. It's more complicated than that, of course, and we'll learn why. Divergent 3D is a microfactory for building cars using 3D printing. But to be honest, it sounded a little gimmicky, so I was curious to hear how it works and how he plans to scale the concept. We learn how a Midwestern boy from a family that never went to college ended up doing global deals for Rupert Murdoch and helped launch one of the most ambitious internet startups of the 1990s. And how that experience translated into the audacity to start a car factory. We also learn what it was like to ride in his new concept car with Jay Leno behind the wheel. We hear about that and a whole lot more on this week's episode of The Art of Manufacturing.
There are a lot of situations where electric cars can be a great thing, and there are situations where electric cars can actually accelerate the damage being done to the environment. So if you have a simple, small city electric car, which people don't seem to like to buy and use, and you are driving it in a place where the power generation is coming from a clean source, that can be from an environmental standpoint, a good thing. If, say, you are China and you're looking at what your public policy is and you think, I'm going to incentivize people to build electric cars, and so the bigger the battery system and the further it goes, the better. And then you look at it from a system as analysis standpoint and you go, wow, they've just doubled or more the damage a normal car would do to the environment, because you've gone from having a 3,000 pound vehicle to a 6,000 pound plus vehicle where you've mined lithium and cobalt and nickel into a massive king size bed format battery. Very heavy, needs lots of vehicle structure. So when it's manufactured, it's very material and energy intensive, very destructive to the environment. And then because you've built this very large, heavy vehicle, it needs lots of energy coming in order to make it move, right?
Yeah.
And if that energy is coming, as it will in China for the next 50 or so years, primarily from coal, what you've actually done is created an analog to the compounding of interest in a money market. You've added weight, manufacturing destruction, fuel destruction, energy use, all into one package that compounds damage to the planet.
So how are you addressing that? Tell me a little bit about your company. On your website, you don't say you're an automotive company. You say you're a 3D automotive manufacturing platform. What does that mean?
If you're going to manufacture cars that are very efficient from a material and energy standpoint, efficient from a fuel standpoint, whether that fuel is coming from solar or from a fossil fuel. You have to look at the overall system that designs the vehicle, engineers the vehicle, manufactures, and assembles that. So you have to look at things from a system standpoint. You have to be able to measure things. You have to be able to measure them from a system standpoint. The system that we use for environmental analysis is a life cycle analysis, meaning all the way from mining the materials to their processing, their use in manufacture, their assembly, their operation, and then finally whether they're reused or disposed of. What does the picture look like when we take the full picture? What are the impacts? So you have to have a life cycle analysis. And then we have to be technology agnostic because, as I had said earlier, someone can go, electric cars, I am for electric cars. In some situations, they may be good. In some situations, they may be terrible. You can't treat technology as a religion. It's simply something that has uses in some places and doesn't in other places. And you have to be able to measure, you have to look at the full picture, and then you have to use that full picture to let you decide whether a technology is useful or not.
So tell me about your first stab at this, the Blade. That was the first. Is this a production car yet?
It's a car that is registered and licensed and drives on the road, but that car was really a tool that I used to demonstrate the technology early on and to get people's attention, to get the public's attention, to get investors' attention, and to get customers' attention with something that showed you can actually use a new system to design, engineer, and manufacture a car, and you can do it in a much more material, energy, and capital efficient way. And it incorporates some new cool technologies, and this demonstrates that. And that was the purpose of the vehicle.
And it's certainly beautiful.
Well, thanks.
Looks like it'll be very fun to drive.
Yeah, it's I would say Cleveland hot rodding circa 1960s meets the 25th century. That's the approach that we were taking.
So describe it a little bit more for the listener because they haven't necessarily. We'll include links, but tell us about the vehicle.
Well, the structure uses our process, which is a combination of standardized, very lightweight materials, primarily from the aerospace industry, that serve as the bones of the skeleton of the structure for the vehicle. And then there are 3D printed nodes, or these are super customized 3D printed connectors that allow you to connect all of the pieces of the vehicle.
So it's like a high-tech erector set almost. So
it's like, the spanning is sort of like the skeletal bone, and the connective tissue are these 3D metal printed nodes that have features built into them you otherwise could not manufacture that allow for very high precision self-alignment and assembly, self-fixturing. The fixtures in some of them are actually located on the pieces. And then channels that allow...
Tell us a little bit more about self-fixturing.
Ordinarily, when you're manufacturing a car, you'll use a single material, usually a steel or aluminum alloy, a couple of hundred sheets of metal, and the design of the car is machined into stamping tools. And then you have to fixture or align those different sheets of metal with some attachment over a half-mile long body assembly line. What we're doing is the connectors, the nodes themselves, can have manufactured features that, say, on a build platform, fit into that build platform so that everything gets aligned very accurately without having to have all of these different attachments across a half-mile long line. So the capital and complexity are vastly reduced, and in a relatively small couple sets of cells, you're able to put together the entire structure of the vehicle, and then using a patented process we have, inject an aerospace-derived adhesive into channels in these connectors, and that bonds the whole structure together. And then you end up having a structure which, in comparison to a steel body car and normal car, won't look any differently, will probably be safer from a crash performance standpoint because you can optimize the structure
And that's
much more.
That's counterintuitive. A lot of people think, oh, crash safety is the biggest issue with a lot of these smaller, sort of these upstart companies and 3D printed cars. But you're saying that actually it's safer.
The safety of a car is less about its weight and more about whether the structure can absorb energy. And if you're able to, with computing power, say instead of, hey, I have one set of materials I'm welding together, how do I create the crash structure? How do I create the zones that crumple in the right way? Now we can take multiple materials, geometries that otherwise can't be used, ways of combining those, and then optimizing them in a structure. So it both gives you a dial-in for safety and also allows you literally out of the chassis structure of a vehicle to take out over 50% of the weight.
Wow.
And that's a massive reduction, particularly for electric cars, where if you're looking, that weight affects the range of the vehicle and the size of the battery system. You know, for one car company, they asked us, a European car company, to take a 5-passenger family sedan and do a case study on what it would look like if we used our manufacturing technology for it. And we were able to take out of the structure over 50% of the weight while increasing the crash safety. And that 50% of the weight was about 138 kilograms. Then you could take tens of kilograms out of the rest of the vehicle because you were downsizing battery system, and then all of the other components can become lighter in turn. So you're creating a virtuous cycle. So instead of the opposite of the virtuous cycle, which is, oh, we don't have enough energy density, so we're going to have a huge battery, and that means we need more structure, which means we need more battery because we needed more structure. You know, then you're looking and going, that's the opposite of the direction that we want to go.
So, gas or electric?
I think it all really depends on looking at that life cycle model and where the vehicle is going to be operated.
So you're not just focused on electric then? People would assume, I would think, that you're focused on making electric cars.
From a philosophical standpoint, I would go back and say I'm technology agnostic. From the customers that we have, almost all of them are looking at electric vehicles. I think the future potentially, and this is what is obviously having an impact on the valuation of the big car companies and technology companies and other companies around them that are looking to disrupt the auto industry. They're looking and saying the big things are, from a technology standpoint, autonomous EVs. So you're having much more simplified vehicles, and they're going to be, level 4 autonomous vehicles. And then you're going to, with mobility services, actually use those vehicles in a fleet. So there's some high asset utilization, of those vehicles, meaning instead of it being parked all day, it's going to be used for most of the day. Our point of view is there's actually going to be 3 big disruptions. If you look, those autonomous EVs and mobility services models, they require, we think, over time, much more flexible manufacturing with lower model volumes. And there's a fundamental mismatch between traditional manufacturing and that vision of AEVs and a mobility services business model. And we think what we've architected fundamentally matches that new system.
Well, that's incredible because the modular system not only is environmentally more sustainable and lighter weight, but also enables you to innovate and change the design on a whim and try all sorts of different new designs.
I mean, the first thing that it does is, say in a normal 3-year from knowing what your design and spec is to actually going to volume production of a vehicle, because you're not doing that hard metal tooling, you're taking 9 to 12 months out of that. But what happens is if you had a new car model or an existing car model and you're going to do a new build of the body of what it looks like, the fastest people are doing that right now is 5 years, 5-year cycles. With what we're doing, you can take that cycle down to even now 2 years. And so over time, fundamentally what we're looking at is, I look and I say, what would the computer industry have been like, and how long would it have taken to, get us to an iPhone 6 if, the motherboard for all of these electronics, was hugely capital intensive and much more expensive than anything else. I mean,
that said, though, some of the biggest waste is from electronics and that constant innovation. So is there a possibility that you might have the risk of contributing to this need for constantly buying new, and that might actually have a negative impact on the environment?
Potentially, I'd say that's a choice that people need to make. In a model where you're doing AEVs, autonomous EVs, and mobility services, the single biggest economic driver for those vehicles is going to be total cost of operation. If you can reduce the cost of factory by 10x, tooling by 10x, and then if you look at the structure that we're using, you look at an airframe for a Boeing 737, it lasts 30 years. It could be modular, so the structure stayed the same, but you put a new motor in, new battery in, new seats in, new body on top of it. That model could actually radically reduce having to manufacture new models, because you'd have the basic structure be like an airframe structure over a long period of time. These vehicles being used in fleets where total cost of operation, including the vehicle longevity, drives the economics. So that would be a way to radically lower the impact on the environment. But what I'd say about what we're doing is, on top of, that potentially longer, if somebody chooses it, life for the structure of the vehicle, at the end of their life, the nodes that join these different pieces together simply can be turned back into powder and made into a new part. And the other thing I'd say over time we have to really look at, and with my team, we're already looking at, is how you create a closed system around all of the inputs that we would use for manufacturing.
Is that still a big challenge, or is that pretty straightforward, do you think, that piece?
The piece for the aluminum nodes is straightforward. The standardized materials and how you recycle the carbon fiber part of it or create new parts out of it is going to take more work.
Recyclable cars. I love it.
Sure.
So tell me about your path. How did you get to where you are? Most people don't just wake up one day and go, you know what, I think I'm going to be a CEO of an auto company.
Certainly I didn't. I mean, I grew up in a very working class family in Cleveland. I was the youngest of 5. No one in my family had gone to college, and nobody was thinking of going to college. I'm not sure why, and nobody in my family is sure why, but my favorite activity was going to the Carnegie Library near where I lived in Cleveland and reading a lot. And on top of that, I had the benefit of being a very good football player. And so in high school, I was near the top of my class and recruited by a lot of colleges for football. And I was going to a high school where they said, hey, you're playing in the Big Ten, you get injured, you're going to be back here working at a car wash, you've got a bunch of Ivy League schools that are interested in you. Why don't you do that? And so I thought, man, I really want to play big time football. Should I really go to a sissy rich kid school? And what happened in the end was the coach of Yale had grown up in my neighborhood and came over and talked to me, and I really liked the guy, and that's where I ended up going and playing football, and it was all cool there. I was,
it's all about relationships, isn't it?
It is, and a little bit of good luck, and so, I loved learning, and I was an All-American football player there in college, so all of that worked out just fine.
What was your major?
I was a pre-med and a classics major. So I had a double major in science. And then
And of course,
later
CEO.
on, I got sort of half a degree in electrical engineering from ASU, which I didn't finish just because I got busy doing companies.
Yeah, so tell me about those companies. You've had a long career as an entrepreneur and in finance too, right?
Sure. You come out of the background I came out of, and you're not thinking, oh, I'm going to be an entrepreneur, or I'm going to create something or start something.
Certainly not back then.
No, not back then. Not back then, and you're not that clued up. You don't know anybody, who's a doctor or a lawyer, much less somebody who's a tech entrepreneur. And I'd say what happened was just through my own intellectual curiosity, I ended up initially going to Goldman Sachs and being put in their technology telecom group and doing technology and telecom related stuff and also media related stuff. And I did a number of major transactions where I did the strategic advisory work for News Corporation, and a couple of cases directly for Rupert Murdoch, who I had a lot of exposure to. And I look back now at what he did there and what we're doing on the in terms of building a satellite platform, and that's really fun and exciting. And so I thought, what, if I could find a pathway to doing that, that would be cool. And I'd say that was the first time I really got excited about business, was seeing an entrepreneur like that doing stuff.
Cool. And I want to ask you about your entrepreneurial career, but I'm curious, just sort of the Midwestern boy ends up working for Rupert Murdoch. Don't usually think of them as becoming ardent environmentalists, or am I totally wrong? Like, is that surprising? Would that have surprised you?
Oh, I was involved in primarily satellite broadcasting related transactions. I had represented Lee Ka-shing family in the sale of Star TV to Murdoch, and then was involved in the BSB Sky merger and the B-Sky B IPO, represented Australian Telecom in Foxtel, which is the joint venture between Australian Telecom and Fox, represented Bertelsmann in the sale of the Fox network in Europe to Murdoch. So those things didn't have to do with my political identification. They had to do with, I'm looking and saying, here's somebody who's really from, look at what satellite broadcasting is doing to China, for example, or other things and in the world. And you're looking and seeing combinations of technology and business having a big global impact. So I wasn't thinking too much about the politics, and my politics, at that point were left-leaning politics in the sense that I went to high school at a Jesuit high school. You had, young PhD Jesuit priests, one of whom had done missionary work in Central America. If you remember, they had the whole liberation theology thing going on at that time. From a very early age, nature was I just loved nature. I'd go out, collect leaves, collect stones, collect lots of different things, organize them. I'd go to the library, read all about biology, biochemistry. What seems funny to me now is, we were talking about systems and ecosystem and what is an ecosystem way back then. But that started, I'd say, in my preteen years. I started looking, and if you remember, there were these books like Diet for a Small Planet. Mm-hmm. All of those were things that I had read and had a big impression on me. Back then, this was the first time that, the damage to air and water were things people were concerned about. I lived in a city where the Cuyahoga River had caught on fire. Mm-hmm. The fire department was using water to put out fire on a river, right?
That's so crazy.
In summers, I had worked at Jones and Laughlin Steel Mill, and you're there and you can physically see what's taking place, right? Mm-hmm. When at the end of the day, you're 16 years old and you're coughing and, black particles are coming out of your throat and your nose, right? And you're looking and going, what are we doing? So
you noticed
I'd say that
you thought about that back then.
Oh, of course. Absolutely. Yeah. Absolutely. And people joke around here. I brought it in one time, but I've kept a book, that I've had since the mid 1970s, which was a very thin book, maybe 100 pages, called Stewardship. And it's all about man's responsibility for the planet. And, obviously I went to a Jesuit high school, so it has how that stewardship relates to spiritually who you are, but that could be, leave aside the religious part of it. It's really, we have that stewardship responsibility for other human beings and for the environment. And I'd say if I was looking at, what fundamentally I believed as a person, that's always been it from a very, very early stage. I mean, I wouldn't be doing this now purely from an economic basis. I mean, I've made money. I wouldn't go in, and this is an enormous amount of undertaking and sacrifice as it relates to my family in particular. I wouldn't be doing this if I didn't think, if somebody looks and goes, what's going to happen? It took us 115 years to build 2 billion vehicles, and we're going to, in the next 35 to 40, build the equivalent of 6 billion more, and they're going to be using lots of energy and destroying the planet. And somebody's got to talk about a solution and figure out a solution that's on a system basis. If I didn't think that was super important and super critical, whether I succeed or not, or we succeed as a team or not, I wouldn't be doing this merely as a business. I mean, this is crazy. I've done this. The first idea came out in 2011. I've been working crazy hours for year after year after year now.
Well, I do believe this is your week that you're supposed to be on vacation right now.
Well, it's actually my vacation week, which means I get to go home usually every day around 3 or 4.
To an empty house because your family's on vacation.
Yeah, that's true. That's true. But, I get home early enough that I can do some exercise and take a bath.
Yeah.
eat whatever I want. Yeah. These little things. No, that's literally, that's, it's the joy of, I ride my bike in some hills around Santa Monica where I live. I come back. I've picked my favorite bubble bass from Whole Foods and select out, one of the bubble bass.
What's your favorite scent?
Well, I love lavender.
Oh, I do too. That's actually really nice.
Yeah, no, it's very relaxing. It's very soothing, and then.
This is the cautionary tale, though, to those wannabe entrepreneurs. It's not all a bed of roses.
Well,
lavender maybe.
Not everybody is trying to create a system that is going to have a factory as a product, right? I mean, that's kind of a ambitious thing. So.
Yeah, absolutely. So I want to get back to that, but just sort of to close the loop about your path, all the more I want to ask you, how did you end up then an entrepreneur? Because if you're very driven by the stewardship, et cetera, obviously, and you ended up doing what really matters to you, but what inspired you to be an entrepreneur?
I'd say, working with people like Rupert Murdoch and Li Ka-shing and seeing these people were doing things in the world that were having big impacts. And it's exciting to fly into Hong Kong or Los Angeles or New York or Sydney or Beijing and be working on a multi-billion-dollar transaction and see what people are doing. And then I said, okay, the thing if you want to do this, you need to be an operator. And so the next step was I'd gotten hired by Bertelsmann, which had been one of my clients, to be the chief operating officer in North America. And, that got me started on the operating side. And then I got hired away to be the COO, CFO of Webvan, which was a big moonshot company that's trying to do what, most of the engineers from that company are actually now at Amazon. They got poached away from Amazon.
You are ahead of your time.
Yeah. So that,
it's not always good to be ahead of your time. In fact,
no.
My very first startup, 10 years before that, was home shopping. So I was even sadder. Even sadder.
There you go. It's interesting. Yesterday, I was just looking at some YouTube TED Talk videos, and Bill Gross, who has Idea Labs, did a bunch of study of why startups succeed or don't succeed.
Yep.
And by far, the single most important weighted factor is timing.
Yep.
Right?
I saw that. That's a great talk.
You're right. It's just trying to figure out what the timing is impossible, right? I mean, there are a bunch of factors that come together and tell you if it works or doesn't work, right?
But you got great experience at Webvan.
Oh yeah, and then I was an entrepreneur in residence at Benchmark Capital, and those things led up to founding Coda, which is an electric car and battery company at the time.
And then you started a car company.
Yes, no, I was a co-founder of an electric car and battery company, and that fit in squarely to love nature, do the right thing, and build something, run fun small teams.
So again, that question of at what point did you realize, and what was that like when you're like, maybe this isn't the solution?
I mean, what happened around 2010 was the National Academy of Sciences, I actually believe it was 2009, came out with a life cycle analysis report. And CODA, at that time, the board and I had a difference of opinion on what the strategy of the company should be. I mean, I thought we should move toward building a ground-up vehicle, and they wanted to do conversion vehicles, taking an existing internal combustion engine vehicle in China and converting it to an electric car. But at the same time that was happening, and I was trying to think things through, we had, in doing the first conversion, car conversion that we had done, which was really, in my view, a way to commercialize the battery system that we had designed. We had set up a battery joint venture with Tianjin Lishan, which was the largest state-owned Chinese rechargeable battery company. And we were looking to use that car to commercialize that system and then move it to a ground-up build car, right? Mm-hmm. So, as Tesla did with the Model S. But the company thought that was too high risk. And at the same time that I was looking at that, I was like, whatever the risk, we had actually spent more in taking this internal combustion engine car, converting it and safety certifying it. And we had to change 80% of the body structure, the sheet metal of the car, which meant all of the retooling in order to safety certify it. So I was like, we just spent more on retooling this car than on all of the technology. That can't be the way in this century that this business works. And that plus the National Academy of Sciences came out with a life cycle analysis of vehicles. And the first line said that the manufacturing phases of the vehicle have far greater environmental impact than the operating phases, meaning the tailpipe exhaust. And I went, what? And then I read that good old 500-page report and I went, wow. Not only is this system economically broken, the traditional manufacturing, economically broken, and broken from an innovation standpoint and product cycle standpoint, it's fundamentally broken from an environmental standpoint, and we're not even looking at the right data in figuring out what the impact is of this product on the planet.
It's like
and nobody's talking
deck
about
chairs
it.
on the Titanic, right?
Instead we're sort of following some tribalism of that's partly political, partly once I identify with the technology, and I'm a green car Evie person, I believe that there's some magic to that. And I just said, wow, if we do this across the board with a bunch of technologies and don't look at the system and don't look at the data and don't measure, we think that, now with technology, we're going to build a brighter future. We can actually lock ourselves into a much worse future. We have to start thinking about those. So I think, that was my aha moment.
Was this before or after you left?
I had read that report before I left, but I really sat down and started thinking about it after I left.
You're listening to The Art of Manufacturing. Join the conversation on social at We Make It in LA and our Facebook group, makeitinla.org/community. We'll be right back after this break. One of the most common frustration of guests on this show is having to worry about the nitty-gritty administrative things like bookkeeping. Well, you know how you can make your life a little easier? FreshBooks. It's a cloud-based accounting software designed specifically for small businesses. It makes it super easy to send invoices and track time and manage receipts, accept credit cards, all those annoying things you wish you didn't have to do when you're growing your business. But you gotta get organized to get paid. And it's way easier with FreshBooks. You can get a free 30-day trial with our code at gofreshbooks.com/artofmfg. And if you sign up now, you'll be supporting the show. A win-win. In this episode, we're talking about how to reduce the environmental impacts of manufacturing cars. But when it comes to reducing the impact of vehicles, another way to save the planet is just to make fewer of them. Did you know that today's cars are parked 95% of the time? It's kind of crazy, actually. So that's where Zipcar comes in. It's the world's largest car sharing network, and it's a great alternative or cost-effective complement to car ownership. Especially if you sign up now, because Zipcar is offering $25 of free driving credit to our listeners. Pick your make and model, choose when and where you want to drive, and pick up the car from reserved spots throughout local neighborhoods. The average Zipcar member reduces their personal CO2 emissions by around 1,500 pounds per year. And they save money because they only pay for what they use. Not to mention, they're not making more cars. Check it out. Go to joinzipcar.com/artofmfg and get your $25 of free driving credit when you join. We're speaking with Kevin Czinger. He's the founder of the new car factory, Divergent 3D.
Can you talk about what it was like? We've had several people on the podcast that basically lost their company in one way or another, whether they had to leave or they had to sell.
Sure.
What was that like? This was your baby.
No, I had put years of being a little bit like I am today. It's sad, but I was, years of being a business monk. Like literally all of your time and energy and everything is structured around, how much of your input can go into your business. And did that for years. And there were long stretches, meaning more than a year stretch, where I would be flying twice a month to China and once a month to Europe, and on top of doing everything else and fundraising. So there's, enormous investment of time and energy. And, when it actually, happens that you're separated from that and you realize it, obviously it has a tremendous emotional impact on you, right? So I listened to a lot of Johnny Cash's songs about being down and out and finding some way to pick yourself back up again. So thank you somewhere up there, and wherever you are, Johnny Cash, thank you.
How long did it take for you to get over that feeling?
Oh, I'm sure I still have scar tissue from that, of course.
Do you have any regrets for the amount of time you spent on that company?
No, I'm not a regrets person at all. It's just not the way that I'm built. Mm-hmm. So my wife always says, somebody does something to you and you immediately forget about it. I'm not a revenge or regret. This is your life. It is what it is.
That's totally me too. I totally get that. Yeah. It's like, look forward.
Yeah. No.
Does she have any regrets about the time you spent on the company?
No, not at all.
No.
Not at all. On that end, all the time I didn't spend. First of all, she has the same politics and stewardship belief and everything else, which is good. And so, thought all of that was very positive. And next month I'll have been married 30 years, and all of my time that I wasn't spending with my business. Thanks. All of the time I wasn't spending with the business, of course, I spent with my family, who I couldn't feel more blessed, I guess.
Amazing.
Is
Kids.
the right word.
Yeah.
Kids. And two, 26-year-old daughter and a 23-year-old son. And they both also went to Yale, and very good students, very cool kids.
So what did you learn from the experience besides the idea behind the life cycle? What are you doing differently based on what you learned from that difference of opinion and that aspect of the business?
Oh, I'm going to look at the entire structure. Don't care at all about what technologies you use, but look to see whether there are new technologies that allow you to meet a set of objectives, and they're moving on some exponential path from a cost performance standpoint, like computing power, like what happened with standardized materials in aerospace, like what's happening in metal additive manufacturing. And then you look at how to combine those and potentially accelerate the cost performance curve of them. But if you look, say, at the overall structure of a vehicle, if instead of going, hey, if I was doing that entire structure by 3D metal printing it, it would take forever to do it and it would be very costly. But if instead you said, well, what do I really want 3D metal printing for? I want it in order to have the features and the geometries and functionality that allow me to, when I take computing power and select all of these other different materials for the body and structures, optimize the connection and use 3D metal printing to do it. Then you're like, wow, this technology combined with these other technologies gives me massive leverage at a system standpoint, not at an individual technology standpoint.
What did you learn from the way you structured the business? How are you capitalized?
Well, at the start, I put in my own money, so, and I have 10-to-1 voting shares in the company. We're going to be doing a Series B, so that will probably change. And I have a board of advisors, which is comprised of General Peter Pace, who is the former chairman of the Joint Chiefs of Staff, Steve Gursky, who is a former vice chairman of General Motors, and the chairman and CEO of one of our investors, Dominic Cerruti. Altron, the company that he runs, which is a Paris-based public company, is also a board advisor. They're the world's largest engineering services company for aerospace and auto, and they do manufacturing of vehicles and set up factories for people like Peugeot and Renault.
So you have some partners, speaking about Peugeot and Citroën, is that right? And
there's a company called PSA that has a couple different brands under it, including Peugeot and Citroën.
So help me understand the business model.
We're still at an early stage. So the system we have, is a version 1.0 of the system. So what we're doing now is working with companies to implement that system, say with a given company on an individual full vehicle. And we're implementing that, getting paid for the implementation. And then when the vehicle starts to be manufactured, we then, given the cost and other savings, we take a licensing fee, which is based on those savings. And the savings are actually very, very large. So the idea is, after we've done a series of full vehicle programs for multiple car makers over the next couple of years, we'll have a standardized platform. We'll have a couple hundred patents around instead of, I think we have somewhere around 70 now, either issued or filed or in the process. We'll have a couple hundred. We'll have some cars that are going through actual validation to become, cars put in people's hands. And at that point, we'll move much more toward, here's a platform and we're licensing that platform so that automakers, large and small, and technology companies and consumer electronics companies that may want to create their own branded autonomous electric vehicle can then use this process, which is much more economically efficient, much more environmentally efficient. And also, if you want to localize manufacturing, allows you to localize manufacturing.
So the manufacturing would first start here in outskirts of LA, but then you could do it pretty much distributed or localized.
Sure. Say you were building 10,000 vehicles. Say the system looks like this, very simplified. You're using a software that allows you to choose the right materials, optimize the structure of those materials for cost and performance including safety. Then you're optimizing how you manufacture and assemble them. That all using computing power and multiple physics models that you're running. So we have a UI that integrates existing physics models and automates a lot of the steps so that you can engineer multi-material modular structure.
You're saying your team, or you're actually providing
our team, and then later on we'll provide the software to an automaker and their team, or a technology company's team, or a consumer electronics company's team will be able to do that engineering with a lot of the steps automated for optimizing structure and manufacturing and assembly. Part of it is obviously going to be standardized materials that are things like honeycomb paneling or carbon fiber shear paneling. Those are the bone parts of the structure. And then the other data for the nodes is simply getting sent to a 3D metal printer. And it can use any technology, right? I mean, there's obviously a cost performance curve, but that equipment is least financeable. It's not like a $1 billion factory. It's actually something where you're lease financing equipment that can be used for any range of different vehicles, unlike a factory that's built for, one or two or three vehicles and costs $500 million plus or $1 billion plus. So You're taking that data, you're printing, you're cutting the standardized materials, and then the entire factory, which used to be stamping and body assembly and e-coating and painting and assembly, those first three vanish, and all you do is have something that looks like a small assembly plant that, once again, is non-design specific. The equipment can be programmed to assemble these, any range of these different structures for range of vehicles. And what that means is, over time, you can have a small team engineer a vehicle using the software, send the data to somebody that's running a printer farm, it gets printed, and then locally you can assemble it. And ordinarily, say you were going to build a fleet AEV locally, just like, municipalities always require that buses be built locally or assembled. Say they require their AEV fleet of 10,000 vehicles needs to be here. Instead of spending $500 million plus with locked in, design in a factory, for that assembly equipment, you're spending about $20 million.
Wow. So
and a building with 100,000 square feet, which is basically, hundreds of warehouses around here, or logistics warehouses, you can simply rent that and you could build 10,000 vehicles within it.
And really the expenditure is mostly the design up front.
That's the engineering expenditure. The capital expenditure is really the fixturing, and robotics that you're using that are minimized because of the way that you're putting together these structures. So it's really the stations that are assembly stations, meaning you're assembling these different connectors and the pieces of the chassis structure into a structure. To do that part of the process is, $750,000 of robotics, almost nothing to say build 10,000 chassis a year using that equipment. And then the rest of it is component assembly, meaning you're putting in a motor or battery system, all the rest of the parts of the vehicle, and attaching the body.
What's the minimum quantity you think would make sense to turn a profit with this model?
It depends on the price of the vehicle, really. You're radically reducing the cost and number, that can be profitable for a vehicle. So if you're looking at a big car company where they're losing money on all of their high mile per gallon vehicles that are lower volume, you can make those vehicles profitably. So it makes unprofitable vehicles now for major manufacturers profitable, and profitable vehicles much more profitable.
Tell me a little bit more about the Blade. Tell me about the sort of the drivetrain, the performance, kind of why you designed it the way you did. Not your traditional looking car. You
want to evoke the animal spirits, right? I was doing it as a technology demonstrator to get people's attention and to get investors' attention and customers. And so I said, hey, it's form and functionality, and you like driving with somebody, but at the same time, the coolest driving position is in the middle of the car. So have people sit tandem. That also, beside putting you in the center of the car in your driver position, it also minimizes the frontal surface area from an aero standpoint. And then I looked at things that I thought were like really cool and beautiful, like a Lotus T90, which is a Can-Am racing car from the 60s that I love, just the swoop of the fenders. And I had a professor from Art Center, Dave O'Connell, who had been the chief designer at Mitsubishi for 20 plus years. And he was teaching then. He's now our designer here. But at the start, I had just hired him as a consultant, and he worked on with me on the ideas, and the Blade resulted from, that interchange between the two of us. The dry weight's 1,388 pounds, and it has 720 horsepower. So it has better power to weight than a Formula One car, like a current Formula One car. And, it's registered. And
how fast does it go 0 to 100?
The 0 to 100 kilometers is, less than 2.5 seconds. For better or for worse, we have the California Highway Patrol across the street from us. So they've already come over and said, Kevin, don't flaunt the law.
We got our eyes on you, right?
Yeah. So, but it's fun. Jay Leno's Garage did a piece on us, and Jay had a lot of fun driving it. And that was the first time that I was really a passenger in the back. Jay's a super good driver.
Oh yeah.
It really blew my mind.
Where'd you go for a ride?
Out in Burbank, there's some hills outside Burbank Airport. So we went around Burbank and then up into the hills.
Yeah. It's a comfy car. Thanks for letting
It's cool.
me sit in it.
Yeah.
So what does success look like then? Because I think this is definitely what I'm hearing is you're not trying to do it all yourself.
Success is licensing to lots and lots and lots of entrepreneurial teams, whether they're in a big car company or a new car company, or 5 or 10 years from now, it's Nike or Gucci or somebody else that wants to, design something and, looks at this and says, hey, you could be a fabulous designer and send data to somebody printing and assembling and get something done, or, a technology company. So, my big dream is what I call wildflower innovation. You create, it's sort of the machine that makes the machine, and you keep versioning it and improving it. And it's super efficient in terms of material and energy and capital, which means it also is in harmony with the environment. And you measure it constantly against its environmental impact through life cycle analysis. And you turn it into an adaptive system by grabbing all of the data from end to end of that life cycle and using that data to inform teams that are designing things and allow them to design things that are, better and better and better and cooler and cooler and cooler, right? Mm-hmm. Because, we have to find a way to use technology not to make humans superfluous, but to make them creative. Very early on, I think in the early 70s, there was a BBC science series, which I think was the first of all of the science series by a guy, Jacob Bernowski, called The Ascent of Man. And as a little kid, I remember he had this one saying that stuck in my mind all the time, which is, the hand is the cutting edge of the mind. And that we wouldn't have mathematics or physics or art or anything if we stopped connecting creation between the hand and the mind. And so what I'd say is, the big vision is to get that technology platform out to make it as low capital cost as possible, so the fixed cost barrier to entry goes away, and then allow it to grab as much information as possible so that people locally can create the world around them. That the millennial generation doesn't look out and say, I'm going to stick to thinking about tailpipe exhaust because the rest of this is just too much, right? There's nothing I can do about it. I think the actual message should be, in the 21st century, the technology was actually there for you to do something about it. And, we've given talks at some of the STEM high schools here and driven around, and I brought different people, including our structures guy, who had been the structures guy for the Dragon capsule at SpaceX and had been, I think, 12 or 13 years at Boeing Phantom Works, and then had been at Apple. And then when he found out what we were doing and we talked to him, he left Apple to come and join us. But, you have somebody like Tonio Martinez, grew up around here, you take them to the school and these kids see what you're actually building, something like the Blade, and they go, wow, that's what all of this studying is about. Mm-hmm. And I think now we should be able to say, you know what, we have the tools to create a new system. It doesn't have to be this material and energy intensive. It can be more democratic in terms of not having the barrier to entry of super high fixed capital cost. And, at the same time, we can build really fun, cool things that are in harmony with how people should work and in harmony with the environment.
Very fun and inspiring. Any advice for an entrepreneur, just to kind of close it out? Somebody who's thinking about starting their business, something that you wish you had known when you first became an entrepreneur?
Whether you're raising capital or you've gotten a customer or any of these other things, at the moment when you think, okay, I can relax, that's the moment when you should sit down and go, okay, now I have to really pay attention to the details, because my thinking that means that this is probably the most vulnerable point of the company.
Can you give an example?
I'd say in general, you see when you're doing things, you just bring in money, people sort of relax, things on the financial side, instead of saying, it's so difficult to get in the rocket fuel for this company. It was super difficult for my investors to create this capital, save this capital. They've got the confidence and trust in us to use every dollar wisely. And what you have to also understand is when you're putting together a company, most of your employees have never dealt with investors, so they don't, or they may have come from large companies, so they don't have that same direct connection and feeling and understanding. They don't think like, hey, the most important thing is don't run out of money, treat your investors well, be very smart, because that each dollar was hard to get and each dollar is critical in its use, right? So, that's one thing. And I mean, here with this company, I try to, even about financing, be very transparent as to where we're at and what we're doing and who we're talking to. And
what keeps you up at night? What is the biggest challenge that you see in achieving your vision? Something that you're not even sure if you're going to be able to overcome it.
I think what we're doing is not it's not really technology risk. It's now sort of you're just engineering solutions when issues come up. There's that one quote from Machiavelli, who basically said that the most challenging thing in life is when someone goes to create some new order and implement it, because the people who have interests with the old order view you as enemies, and the ones who could benefit from it are lukewarm. So, you need a bunch of different forces. Here, I think we have the autonomous EV forces and mobility service forces at the same time, where people are looking, how are we going to manufacture these things? How are we going to localize manufacturing, right? How are we going to have a faster product cycle, right? So that fits in, but it's obviously, that go-to-market adoption thing to me is the critical, most challenging part of what we're doing now, not technology and not solution engineering.
Anything else I should have asked?
My favorite color is liquid orchid. That's the color of the blade. How's that?
I love that color. You do like purple. You did pick my purple business card too.
Yep.
And you like lavender, as we know.
Yeah, sure. Yeah.
Awesome. How can people learn more?
Divergent3D.com.
This has been great. It's so inspiring and really fascinating what you're doing, and counterintuitive, but it makes so much sense once you hear it. So I think it's just really, I'm excited for you.
Well, knock on wood. Knock on wood.
Thanks so much for coming. For having me, I should say.
I think it's fascinating how humans, when we learn something, our brains are kind of wired to try to simplify things, and then we try to apply that new belief to every single situation. And so it's totally normal. Like right now, most of us think that one of the best things we can do is to convert to electric vehicles to save the environment. But the conversation I just had with Kevin Czinger is a really good reminder to just take a step back often when you're innovating, whenever, and to kind of rethink those assumptions and just take in new information and not be too tied to any one particular belief or assumption. Kevin isn't the first entrepreneur we've had on the show where he's had to let go of his previous company. For example, Carl Kanai, he almost lost the rights to his name. Connie Huffa went bankrupt because a partnership went wrong. And Greg Steltenpole, he had to sell Adwala and basically sell out to Coca-Cola just to survive the apple juice recall. These are just 3 examples from our past episodes, and like Kevin, they've all come back with a vengeance to try again. And I love to watch the passion and determination of an entrepreneur who's making a comeback. I found it really interesting to hear about Divergent 3D's strategy and their target customer. They're not looking at the ordinary consumer like we might think, but their business model starts from the assumption of a future in fleets of autonomous vehicles. And with that in mind, things like low capital costs are really important. So he's mission driven by personal values like sustainability and stewardship, but the business proposition to his partners is pure capitalism. Kevin's microfactory can go from concept to production in less than 2 years. And that leads to a design iteration and innovation on a scale that we've never seen before. And so ultimately, if he can make only 10,000 units of a brand new car, for a company that wouldn't normally be in the car business even, and be profitable, he's bringing about a sort of democratization of car manufacturing. And I think that's super fascinating. And finally, I always love to bust myths. It's not enough to make products less wasteful or put a green label on it. And we see a lot of that, the whole greenwashing thing. But If we're aiming for sustainability, as we should, it's critical we consider the systems perspective and rethink how things are manufactured in this world. Time to wrap it up for The Art of Manufacturing. Visit our website at www.artofmfg.com for more details and show notes. And make sure you're subscribed on iTunes or your podcast player so you never miss an episode. To chat with other like-minded makers, join the Art of Manufacturing Facebook discussion group. This podcast is produced by At Large and Dangerous in collaboration with the Make It in LA initiative and other partners. A big shout out to Peter Brandenburg, the producer and audio engineer. Thanks for listening to The Art of Manufacturing. I'm Z Holly, and remember, don't just make it, make it.